Good afternoon, everyone. Thank you for joining the Basic Fire System Design webinar with Rexel and Eaton. We're going to give it about 3 minutes just to let more people join. So we'll start at about 12:03 and I'll pass over to Paul Walsh from Eaton. Also, just a reminder as we're waiting, you should see a handout button where there is a guide that Paul will go through, but that's for you to download and that's in handouts. Any questions, please put them all in the question box and we'll do questions at the end of the webinar. Lovely. Just a quick reminder. So again, to anyone that may have missed it, we have a handout attached, which will be under the handout tab just for you to download. And all questions, please put in the question box and we'll answer them at the end or we'll get back to you after the webinar. Ready when you are, Paul.
Okay, thanks, Jamela. Good afternoon, everybody. Welcome to a lovely wet Friday, but hopefully the sun will shine this weekend. Lots to get through today. Quick introduction, I'm Paul Walsh. I'm the UK sales manager for the fire products in Eaton. I've been in the industry for 20 plus years. There's a lot to get through, as I said, about 90 slides. So obviously questions may get picked up afterwards. I think Jamela had said that if you've got questions in the chat box, then it might be a case that we collate those and come back to you after. As also Jamela had said, there's our handy design guide, which is a pocket design guide or PDF version now for you, that just has some good details on some of the things that we're going to just cover today. 5839 is a huge document, so this is a 90 sort of snippets out of that particular document, just to give you some ideas of some of the hazards and some of the issues you can face in a fire design environment. Obviously, we're there to support you guys with a team in Doncaster of design engineers and our salespeople, obviously out on the road if we need to do surveys and things like that. So we'll crack on. So today's CPD is to obviously specifically about oh, where's that gone? Why am I not getting that up there? Technical issues. So I think because it's accredited, you can get certificates. So that's something that we can sort out afterwards with Jamela and the team. Just an overview, the requirements and the categories of the standards, any of the design considerations that you need to take. Obviously, the limitation of false alarms, installation, commissioning, maintenance, and the user responsibilities. The objectives of the learning objectives, the overview of some of the applicable standards when discussing fire systems, some of the understanding of the standards and any of the categories, identifying some of the key objectives when you're installing, maintaining or commissioning, and an overview of the responsibilities and obligations that you can make your clients aware of, or in turn you're also aware of. So there are many different standards within fire or codes of practice, and that's quite critical actually, because 5839, whilst it is a good guide, it is only recommendation. So there are ways around it, which I think we'll cover in this document, or as long as you notify it as a variation. So you've got 5839, you've got 7273, BS 999, BS 6266, HTMs, Code of Practices, 7671s, and a lot of these have got CPDs in their own rights. So don't worry, because 5839 is the fundamental part of the design of a fire system. The others are some of the ancillary equipment that goes on it, and some of the other codes of practice for building control, etc. Click. Right. So the overview. So the 5839 is the application standards for fire detection and alarm systems, and as it says in brackets, code of practice. So it's not you must, it is you should. Code of practice is obviously for designing, installing, commissioning. Part 1 is what we're talking about today. Part 6 is the other side of it, which is to do with more about the dwellings, if you've got houses of multiple occupations or flats and that type of thing. And the RRO, which came into force in 2005, which is legislation and is law, and that's about how somebody has to take responsibility for their own risk assessments and reducing the hazards and things like that within their own premises, because fire certification does not exist. The fire brigade do not produce fire certificates any longer. Won't dwell too much on this slide, but as you can see, it's been through a number of revisions and is still probably going to be revised as we go through, as technology improves, etc. Or in some cases, when things happen, such as a Grenfell, things get written. I know there's a new document, BS 8629, and that's come out recently in light of Grenfell. So another one that we can probably do some training on and updates on. Sorry, there's the dates. So you can obviously buy a copy of 5839. It's quite a lot of pages, and we're going to cover some of the real key fundamentals. And in your handouts that we've got on LinkedIn on a PDF, some of that will be captured in that for reference. We use that still in our world, because when you do it daily, it doesn't mean that you know it easily. So it's a good check. So the standard is 7 sections, 48 clauses, 7 annexes, and there are 20 principal changes from 2013 if you are familiar with 2013. So the content covers the planning, the design, the install, commissioning, and maintenance, and then the certification. And that's quite important, because as you do all this, there are certifications for design, install, commissioning, and maintenance. And those certificates should be in place in a fire binder or fire log within the premises of the building. I know a lot of things that don't happen, so no design certification is issued at that stage. Install certificates sometimes don't get done, and certainly commissioning certificates sometimes can get missed. But without those, you're really leaving yourself open to the fact that the system is non-compliant. So if anything did happen, and obviously remember it's a life safety system, then you could be liable. And obviously with Grenfell, we know that somebody's probably going to end up facing some prison charges if when the case comes to court. So 5839 itself, there are lots of commentaries, lots of recommendations. It's a must or shall are used in the law, not in the code of practice. So as I said earlier, this is recommendations, and therefore it can be treated with some understanding that not everything can fit, so you might have to put a variation in to a design. But as long as you make a note of that variation, then that's quite acceptable. As long as it's, I haven't put any detectors in this building, it needs to be quite pretty reasonable. So 5839 does cover non-residential, so it's commercial properties, which is mostly what we put fire alarm systems in. Most dwellings, unless they're now high residential flats and big buildings, generally only have smoke alarms for mains powered or domestic smokes, and we as Eaton do not make those. So within the document, clause 1 defines the scopes, clause 2 lays down the normative references, and clause 3 picks up T's and C's, terms and definitions, not conditions, used within the standard. So if there's any acronyms or anything like that, you can pick it up in clause 3. So when we talk about the need for a fire detection, who should make that decision? Well, the developer, the purchaser, the user, the consultation with other stakeholders, such as insurance companies, and obviously driven by a risk assessment, which forms part of the regulatory reform order, which we touched on earlier, which is law. So if you own a building, you should have a risk assessment in place, and that risk assessment should cover the fire alarm system, and then that would lead to telling you what need you have for a fire detection system. And we'll come on to things as in the types of fire detection systems you need. So when you look at a need for a fire detection system, then you've got to select what type. Are you looking at life protection or property protection? Most insurers will just look at property protection because they're not really worried about lives, as harsh as that sounds. They're worried about the asset. And obviously then, as part of a obligation or morals, you have to look at life as well. So generally most buildings have a life protection system in it, which is an L system. You look at if there's people sleeping in the building, if it's low occupancy. Obviously if there's no one sleeping in it, then is it manual systems or is it detected by systems or people? If it's small and open plan, sometimes you can get away with no fire alarm system, but that's very few and far between. Property protection, as I touched on earlier, generally comes across from a insurance recommendation as opposed to a risk assessment. So as we say, categories of system, you've got P for property, and in my experience, it sometimes starts off as a P system. It might be in a document somewhere, and it generally moves into an L system as you get into more of the detail, because property protection is very few and far between when you've got nobody that is in the building. There are certain jobs I've done in the past where you've got, for instance, high expensive works of art, so you've got nobody in the building and it's just purely protecting the asset, and therefore you can get away with a different level of detection, or sounders and call points can be omitted because you're not trying to evacuate the building. So as you can see there, P1, you've got automatic fire detection throughout. P1M is a throughout and call points, because you don't have to have call points with a property system. And P2 and P2M, again, they're just a lower level, because that's where you have it specified or where it's designed under a risk assessment. But generally speaking, the majority of systems that you'll see in everyday use will be an L system, which is life protection. So we're trying to make sure we can get people out of that building, not because they're going to get burnt by the fire, it's to do with the smoke. So it's obviously to get them out of the building before a smoke situation prevents them from doing so. The different levels, you go through L4, which is just alarms in, detection within the escape routes and the circulation areas, such as stairwells. And L3, it's the same as L4, but then you add on some rooms that open onto the escape routes. L2 is the same as an L3, but it's a risk assessment driven design, and your risk assessment then determines if you've got any other rooms outside of that defined in the standard that you might need detection in, and that could be an insurance driven thing. So you can't really do an L2 design unless you've got a risk assessment, and an L1 is just detection in all areas, and obviously then all your sounders and call points, etc., etc. You have also an L5. It's very, very rare that you would get involved in an L5 system. It is there, but I wouldn't worry too much about it. That's a risk assessment, very specific type of building, and you'd have to have that signed off by quite a number of different people. You've then got a manual system only, so no detection in it, just call points and sounders. Obviously, the little note there is that all the L1s to L4s include manual operations, so you need call points and you also need sounders. So that's just a resume on that. So M, L4, L3, L2, and L1. So just some notes. The detection types on the escape routes can be optical smokes or optical smokes multi-mode. So that's heat or carbon monoxide, and that is spaced as heats. So you've got to be careful with that. If you're using heat detectors, there's a smaller footprint that they can cover. In the category L2, all areas in addition to L3 should be clearly defined. As I said earlier, it's good practice to get a schedule of those. And an L1 system is everywhere. There are some exceptions. So you can basically risk assess out toilets and shower rooms and bathrooms, toilets, lobbies, stair lobbies, small cupboards less than 1 meter squared, and voids that are less than 800 deep, if there are any voids within the building. You still require sounders in those areas, so you still need to achieve a certain decibel level, which I think we'll come on to later, but you don't necessarily need detection. This is just a little bit about exchange of information and the definition of the responsibilities. So the user, purchaser, and owner of the buildings, they should have a consultation at the design stage. Sometimes they have to go into dialogue with the responsible authorities, such as the fire and rescue services, local authorities, building control, and obviously then consult with their insurers to make sure that they've got the right level of detection for what they need, and not leaving themselves exposed. The designer of the system obviously should ensure that, to the extent that is appropriate, there is a consultation at the design stage with the relevant parties. It's difficult. Some of the larger jobs generally have consultants involved, but some of the smaller projects that you may see don't have any of that, and it's purely pretty much a D&B, and therefore everyone's up to their, you've just basically got to make your clients aware that there is some obligations and they have to consider this. So the installer, so whoever's installing it, which is generally, I guess, most of your clients, they should ensure that, to the extent appropriate for them, that they've got to make sure that they have consultation with a designer, if there is one, the end user or the purchaser, the supplier of the system, so that might be us, and then if there are any consultants involved, cross-checking the information with them. In clause 6, again, this is just before an order is placed, the responsibility for each of the following system design, installation, and commissioning should be documented. As I said earlier, that's quite critical. There should be a certification process, and I think there are a number of different variants to that. So there isn't one rule, one standard one. You can have a different certificate under the NSI certification as to the BAFE certification. Any variations which I touched on earlier, should be also noted, and they can be noted on the installation certificate, they can be noted on the design certificate, but basically they should be noted on the commissioning certificate. So if there are any variations to the system that don't fall in line with the standards, if they're documented and approved and signed off, then it's all good to go and everybody's covered. So if there is any issues further down the line, why wasn't there a detector in a certain place? It's got a journey and a history about it. So in section 3, we're going to consider the design considerations. So there's relationships between the categories and the protected areas. So the category is just a shorthand of describing whether the system is manual or automatic. And in the case of obviously the automatic detections, the objective is to the objective of the automatic is, so we need to understand what that is as well. The appropriate extent of the automatic detection is normally determined by a risk assessment, as I touched on earlier. And normally the risk assessments are the responsibility of the owner of the building or the end user. And these clauses are sometimes a bit too much detail for what we're going to cover today, but they're definitely something to be aware of. So if you are linking into other systems, so whether that is extinguishing systems, gas suppression, when you're holding open fire resisting doors or opening locked doors on escape routes with access control systems, shutting down AC stuff, or smoke vent control, and obviously grounding lifts if there are any. And as I said earlier, BS 7273 is another massive document, and part of that is to do with things like door holders and how they should operate in when they're linked to a fire alarm system, and that's for another day. Clause 10 talks about the systems in explosive gas or dust atmospheres. So again, you need to consider any system or part of a system that's protecting that area with cables passing through it, where there might be explosive gas, and all that should conform to other standards. So again, lots of detail there, but perhaps something that needs to be picked up at a later stage or just be made you aware of. So under the CPR 2013, components are required to conform to harmonized European standards, so EN54. So we've got BS 5839, which is the UK standard for installation, design, etc., but manufacturing standards fall under EN54. And obviously you've got to make sure that whatever you're buying in the marketplace has that conformity. And obviously, as we move through, I guess, with Brexit and move away from Europe, that might change. Again, some system component examples of standards they should comply to. Interestingly, the one at the very bottom has been more of a topic recently in EN54 Part 23. And that's to do with visual alarm devices. So does it have to comply to EN54 Part 23, whether it's a visual indicator device or a visual alarm device, a VAD, and there's a difference between the two. Again, something that, you know, either I can pick up with you later on, etc. Obviously, these systems need to be monitored, whether that's locally monitored or off-site monitored. Your critical signal paths, power supplies, and fuse monitoring, they should be all in fire-rated cables. The removal of any device should be indicated at the control panel, pretty standard, but some systems that don't comply don't have that. The removal of a detector, that should not affect any call points. So there's lots of little bits and pieces, and one fault should not affect more than 2,000 square meters of like a zone of protection, and two faults should not affect more than 10,000 square meters. And they're generally in the bigger systems where you've got lots of different zones and obviously lots of devices that fall across different floors. Again, monitoring the integrity and the reliability. So alarm devices should be used by only capable of being removed by a special tool. Sounder circuits.
Hi Paul, sorry to cut. We're just having issues seeing your screen. It's gone back to the title screen.
Oh yeah. Why has that happened then? I'm not looking at that one, I'm looking at a different one. How strange, because mine's on the presentation mode. Is that better?
Lovely. If you just want to go back 2 slides just so we can recap.
Cool.
Thank you so much.
No problem, sorry. Okay, so just talking about the different manufacturing standards for EN, and that's our problem, not yours. But you, as a I guess a purchaser of those or an installer of those, need to check to make sure that they're compliant. Again, we are talking about a life safety system, which does get really heavily vetted if there is any issues. And then we talked about the integrity and the reliability of the monitoring equipment, whether that's locally or off-site, and also zones, and about how they shouldn't, faults shouldn't be affected. And that we can help you with. So if you've got a design that needs doing, we'll make sure that it complies to those types of things. So again, minimum of 2 sounder circuits from a system, single alarms in the vicinity of the control indicating equipment, and 2 or more sounder circuits should not be contained within the same common cable sheath or tray. So you should try and do some diverse routes. Again, that sometimes falls under a different standards where you've got obviously electrical, you know, the whatever edition they're on now, 18th edition, 19th edition. You've also got detection zones, and we'll come on to alarm zones in a second. So buildings less than 300 square meters, they can be regarded as a single zone. But if the total area exceeds 300, then the zones are restricted to floors, and then a single zone should not exceed 2,000 square meters. Any stairwells, lift shafts, or vertical shafts, such as risers, should be considered as separate zones, and the maximum search distance within the zones to locate the fire from the point of entry should be less than 60 meters. So if a fire brigade entered the zone because it's a conventional panel, from that point of entry to the zone, they shouldn't have to travel more than 60 meters. And that's not as the crow flies, that is practically 60 meters. They shouldn't have that. So you should be looking at that in your designs. And for a category M system, a single open area is maximum up to 10,000 square meters. Again, M systems are very, very few and far between, because most insurers want to protect the asset. Alarm zones, which we talked about, which are different from detection zones. So they're the boundaries they've got boundaries that need to be fire resistant construction. And again, that needs to be understood within a design, and it's very, very hard to sometimes come by that information, as I know. You're looking at different sort of types of, you have to have common alert and evac signals. You could also have phased evacuation if it's a large building and you don't want to tip out everybody at the same time, because you end up with bottlenecking in corridors and stairwells. So sometimes it's floor by floor. Within the space, the alarm zones, you can have multiple detection zones in the same alarm zones. So, but not the reverse. Again, in a design situation, we would make sure to help you guys, if you had that particular issue, we'll make sure that we cover that when we do our designs for you, or our design intent. So sometimes obviously systems that do have alarm receiving centers or report straight to fire and rescue services, there are standards that they need to comply with and the equipment needs to conform to. And generally speaking, they're generally always provided in like residential care homes and also in category P systems. So if you've got a P system only, you need to have an off-site monitor of that if it goes into fire. So just moving into now, which we spoke about earlier, you've got your smoke detectors, you've got your call points, but you obviously need to make people aware there's a fire. And in the standards, they talk about a common sound level of 65 decibels. And then 60 decibels can be in quiet areas. Again, if you're working off drawings, how you define a quiet area is tough. So I generally always work on 65 dB. It shouldn't exceed 120 decibels, which most manufacturers' sounders don't, unless you're into industrial stuff. And then you should be 5 dB above any background noise. Again, how do we know what the background noise level is? But you've got some information in the back of 5839 that gives you some standard background noise levels. If you're in a hotel or any of sleeping risk accommodation, you should be achieving 75 decibels at a bed head, so where you sleep. And again, attenuation of sound. If you're going through a standard door, you lose around about 20 decibels. If it's a fire door, you can lose 30 decibels. So again, that needs to be considered when you're looking at your design. The common theme is every time the distance doubles, you lose 6 decibels. So in a situation where you've got a 100 decibel sounder at 1 meter, when you move away to 2 meters, so the distance has doubled, you then reduce your sound pressure to 94 decibels. And then from the 2 meters to 4 meters, to doubling the distance again, you then drop your sound pressure levels to 88 decibels. So as you can see, it doesn't take long to lose your sound pressure. And especially in a bedroom where you need to achieve 75 at the bed head, you almost have to have a sounder within the vicinity of that room. So in most hotels, they generally have a smoke detector with a sounder base, and sometimes obviously nowadays a visual alarm device, which brings me nicely into visual alarm devices. So this particular standard, EN54 Part 23, came into effect back in 2014, and manufacturers had a huge problem trying to comply with it, and still some of them do now, because it's quite onerous. It's almost similar to that of the sound pressure levels. So light behaves in different ways, and again, it's very difficult to measure a flashing light in terms of its lumens and lux outputs. So you have to refer to manufacturers. That's the only way of it basically in design, is to look at the manufacturer's information and their technical data sheets to show how the light spreads. Mostly if you put a VAD in a small room, you'll be covered. It's only when you start building up lots of VADs in big spaces that you can sometimes fall foul. And again, they genuinely come into play in that scenario in large projects. Most of the small ones, if you put, as I say, put a VAD, whether that's ceiling mounted or wall mounted, you can usually comply, as long as they're in sort of line with the sort of detection standards as well. So if you've got an L1 system, you should have, you know, as many as the VADs virtually like for like with the smoke detectors. So if there's one smoke detector, you need one VAD. If there's then 2 smoke detectors, you'll probably need 2 VADs. But then you've also got VIDs. So just to confuse everybody, a VID is a visual indication device, as you can see. They're not EN54 Part 23 compliant, but they are EN54 compliant. And they are supplementary notification. And generally, most buildings, you can get away with that, because if you're not using VADs as a primary means of notification, then, you know, normally it's the sound pressure levels, the sounders that do that for you. So using a VID is sometimes acceptable, unless the specification or the documents call for VADs, and that might be because the sound background noise is much higher and you can't achieve the sound pressure levels, or it's a building where you just don't know who could be in it. So you could have somebody who's got hearing issues, so therefore their primary means of notification might be the visual, in which case you would need to install VADs. I'm not going to dwell too much on this, but as I said earlier, there is manufacturer's standards in terms of how the performance of the light behaves, and everyone's different because they're all using LEDs and they're all using different power LEDs, different colors. So you'd have to consult with the manufacturers to make sure you comply, or the manufacturers themselves will help you with the design as we can. Difference again for the ceiling mount versus the wall mount. So similar problems. It's just about looking at that and being aware of it. And if you need to do a compliant EN54 Part 23 VAD design, you need to consult the manufacturers, whether that be us or another. You have got an EN54 Part 23 open class category, but again, that needs to be manufacturers. That you need to check with them what they intend it for and specific applications. So it's maybe for an existing design that cannot meet precisely the EN54 Part 23 coverage, but the open class product needs to have its own coverage data well defined by manufacturer to make sure that they've got effective application. So you've also then got devices for people who are hard of hearing or deaf, and they can be fixed, movable or portable, and how the fire alarm can interface with those just depends. So you can have vibrating pillow pads in bedrooms. You
Hi
can
Paul, sorry to stop you again. The presentation stopped.
Yeah.
Yes.
I don't know why it's doing that. I'm not looking at that screen. Is it back again?
Thank you. We can see now. Yes, thanks so much.
No problem. Strange. So yeah, so fixed warnings for people deaf or hard of hearing. There can be many of the different types and the interfaces that go with those for the fire alarm system. So you have got deaf alerter, which are pagers that they can carry around with them. So those need to be considered, but they have to be compliant as well. And obviously the critical path is making sure that that person gets that fire signal just as if the fire alarm has gone off with sound pressure levels. We also talked about them for VADs, moving for pillow pads and pagers. Sorry, I didn't click. Again, in some of the larger projects that you may come across, there are staged fire alarm systems. So that's phased evacuation, high level buildings, shopping centres, generally where people, there's a lot of people involved. Therefore, you can't just tip everybody out of the building at the same time because you'll get bottlenecks and stampedes. So we've got a situation, hospitals, generally, they use a progressive horizontal evacuation, patients moving sideways, until the fire brigade maybe have to take them completely out unless they get under control. So there's different staged alarm systems and cause and effect, as they call it, for different building types, and you just need to consider that when you're doing it. Most of the smaller systems are what they call one out, all out. So literally, fire alarm goes off, everybody evacuates. It's only in the large projects, let's say the large buildings, where you need to consider phased or staged evacuation. Manual call points, which we touched on earlier, they've got their own little standards and how you install them. This is more about the installation factors, about 1.4 meters above finished floor level, plus or minus 300 mil. And that's to comply with the Disability Act. Again, if you're in a wheelchair, you can't have a call point too high up because you couldn't reach it. Search distances within the space, there should be a maximum of 45 meters. Again, we touched on that for the fire brigade in terms of 60 meters for finding a fire within a zone. And nowadays, which is critical, they should all be fitted with a protective cover. Ironically, in 2013, I think it was a variation if you put a cover on a call point, because it was a double action. You had to lift the cover to press the call point. Nowadays, in 17 version, it's a variation if you don't have a cover. All of ours come with the option of plastic covers, and it helps to minimize false alarms from people just being the devilment factor of breaking a call point, whether that's in a school or not. And obviously, if it's a real problem, you can get ones with sounders on them. So if you lift it a siren goes off before you even get, so it even has a more of a deterrent than a standard plastic cover. Well, types of fire detectors, we touched on some of them earlier, and their selection process. So you've got heat, smoke, combustion gas, infrareds, UV, and the selection is based on what the speed of response is needed to also minimizing false alarms within that space and the nature of the actual fire hazard. So whether that's a chemical fire, a slow burn fire, etc. And the choices should be documented and again issued in the system documentation. When you look at spacing, and again, the design guide that we've given you as a handout will give you all this information in a smaller version. Your smoke detectors, again, have got a 7.5 meter radius of protection, so 10.6 by 10.6 square. They should be at least 500 mil away from the wall or any obstruction. They shouldn't be within 25 mil of the ceiling, but that's okay because most manufacturers, in fact all manufacturers, have that already covered. So when you fit it to a ceiling, the base pushes the detector away from the ceiling. So you're not going to be generally within 25 mil unless you try and flush it, and not further than 600 mil from the ceiling. So you can't be too low. The heat detectors, well, the radius reduces, so you end up with a smaller protection space because they're obviously working on heat rather than smoke, and obviously heat is a harder to pick up quicker, so they have a condensed more detection in the space, similar to the smokes, but they shouldn't be any more than 150 mil from the ceiling. So when you look at detector spacings, and detectors in the apex as well, they need to be at the highest point you can get to, and again there is a calculation that you can use which you can increase the detection spaces, because obviously when you've got an apex ceiling then smoke travels faster into that space, so you can reduce or increase rather the actual coverage. But you should, and then you can increase that by 1% per 1 degree of the ceiling slope, and that's up to a maximum of 25 degrees. Generally speaking, when you've got high ceilings and that sort of thing, you have to move away from smoke detectors anyway, because you've got a maximum height that they can be sighted at. So corridor spacing, if the width is less than 2 meters, you can then increase that distance from 10.6 to 15 and 7.5 to 10.6 for smokes and heats. But the maximum spacing from the end wall should be back to 7.5 and 5.3. So yes, you can get less detectors in the corridor as long as it's no wider than 2 meters, and that just reduces some of the costs involved in protection of corridors. And you also need to make sure, if you are using a multi-sensor, then you are using it as a heat only in certain circumstances, that needs to be considered to be heat spaces, not smoke spaces. The spacing and sighting of automatic fire detectors, again, you need to be thinking about obstructions that are 250 mil deep, because that could potentially mean you've got to put one on either side. So if they are more than 10% of the ceiling height, you need to treat them as a wall, and then obviously make sure they're not close to 500 mil. So if you've got a room with a big beam in the middle of it, you might have to put 2 detectors in it to meet the standards. The spacing and sighting of the automatic detectors, if you've got partitions 300 mil or less from the ceiling, that also needs to be treated as a wall, and the detector again needs to be 500 mil from the partition. When you've got forced air vents, you need to be not within a meter of those, so again you need to space your detectors accordingly. I've seen lots of installs, and I know it says that sometimes that's where it goes on a drawing. The common sense from the installer has to prevail, so they have an obligation to make sure that they're not putting it within a meter of that forced air vent. because obviously if you're forcing air through that, then you're pushing smoke away from the detector and stopping it performing. So vertical flue-like structures, you should have a detector at the top of the shaft, whether that's a riser or a lift shaft, and that should be within 1.5 meters of the opening on each floor as well, and that applies to L1 to L3 and any P1 designs, and again L5 and P2 you can consider that if you're doing that at design stage. So stairways, detectors, again you need one at the top of the stairway, stairwells, and then one in each main landing. So not sub landings, just main landings. Voids and lantern lights, generally not required if the space is less than 800 mil. So if you've got a less than 800, you don't have to have a detector within that space. So the control and indicating equipment, again, that needs to be sited at a suitable point for the fire brigade and staff access, and normally on the main entrance. It's normally communal access in case of multiple occupation. Obviously, the manufacturers have to comply to zone lights and optional displays, and zone diagrams are an absolute must, whether that's a conventional by-wire or addressable system. 24-hour standby and 30-minute alarm capacity with the batteries is a must. Obviously, that can be increased if there's maybe a 72-hour requirement if the building isn't going to be occupied at the weekend. And obviously then you have to authorize access to controls to make sure no one can just switch it off whenever they fancy. If you're looking at bigger systems, network systems, the sub panels, so if you want, say, in a riser cupboard, they don't have to have any indication and they don't need to be visible. But obviously all their network links should be monitored. And again, you can use standard cable if it's in the loops, but the standards will tell you about when to use the enhanced fire cable. Power supplies, as I touched on earlier, it's got to be dedicated mains to the fire alarm, single pole isolation, and a fuse spur. Fire resistant cable must be used, and it should be derived from the main distribution board if possible. If not, it might have to be put down as a variation. Again, power supplies, standby supplies, you've got rechargeable batteries if you've got an automatic charger. The installation date should be visible. Recharge within 24 hours. We talked about the 24-hour standby plus 30-minute full alarm. And that can be reduced to 6 hours if main supply is backed up with an auto start generator. Again, that would be considered if you know that in the building. And category P systems, 24 hours longer than the unoccupied time, up to 72 hours. And obviously you've got a link to the alarm receiving center. Cables and other interconnections, they all need to be fire resistant. That includes the main supply, whether using the network cable or the loop cables. So you've got standard cable and enhanced cable. And as I say, mostly so the loops can be generally in standard cable, but any networking perhaps needs to be done in enhanced cable because it needs to be basically the system integrity needs to remain there across the network as opposed to the local loops. Any supporting clips need to be fire resistant. Generally, we try and segregate the fire cable within the tray from other services, and it's obviously got a red color to distinguish it from other systems. If you're using radio systems, then it needs 2 independent power supplies, mains and battery, 2 primary batteries, primary battery and secondary battery. System should also have comprehensive radio survey pre-installation to make sure you get signal. But again, as a manufacturer, we don't make radio systems, but there are, obviously they do exist, and some of them work really well. Electromagnetic capability, again, that's to do with manufacturing standards, etc. So that's not for the designers to worry about. And again, electrical earthing, again, it's more of an installation perspective. So that brings on to some of the things that we have to consider about minimizing false alarms or limitation of those. So it's generally down to the end user to make sure that that happens, that they make sure that the day-to-day operations and maintenance are done correctly. If the design is wrong, then maybe that needs to be changed. We should log all the false alarms. They need to check their logs, make sure that new systems of more than 50 automatic detectors should be soak tested for 7 days. I'm not sure that happens.
But sorry, it's
Oh,
gone back to the first slide again.
Yeah. Sorry, I don't know why that's doing that.
It's fine. Thank you for everyone mentioning the question section. Appreciate it as well. There we go. Lovely.
Yeah, I'm trying to keep my eye on 2 screens and I'm struggling. Okay. Okay, so installation. So there are responsibilities of the installer, as we touched on earlier, because they should be looking at compliance with design, any variations. They should be compliant to the relevant sections of this standard in terms of what their obligations are, and then they should install it within manufacturer's instructions. And then on completion, they should issue a certificate for install. There are obviously installation practices and workmanship, so they need to conform to BS 7671, all metal fixings, etc. And they should again comply with any of their NSI or whatever their governing bodies are. Again, this is all down to installation, volt checking, and bits and pieces that they have to go with impedance testing. And then finally, in the commissioning and handover, again, this is where this is documentation. The commissioning should be carried out by a competent person. So whether or not that's a conventional system, by-wire system, or an addressable system, there should be a competent person should be carrying out the commissioning and providing a commissioning certificate, and to make sure that everything's installed and correct. Because if you don't have that commissioning certificate, the system is almost deemed non-compliant. So documentation we talked about earlier with certificates for each part of the system, the O&M manual, then as fitted drawings, any electrical readings that are relevant, the sound pressure levels if that needs to be done, and then the logbook including variations and any radio system information, etc. And those are the models of certification. So in the standards, it's model G1, G2, G3, and G4, which are in Annex G for your design, install, commissioning, and verification. So the verification is if you make alterations to the system after install. So if you had an L2 system and you wanted to upgrade that to an L1 system, you do that work. You then have a verification system to say that that's compliant to L1 now, just to basically keep the journey intact. Again, they talk about an acceptance certificate. I don't think I've ever seen one, but the client should sign off and say he's accepted the fire alarm system. That generally is never done, but it's part of the documentation. I don't think that would be a problem if it wasn't done. In terms of the importance factor is the design, install, and commissioning certification. And we touched on the verification certificate earlier. That needs to be something that you can use for any changes or any further down the line after the install. This is obviously capturing the whole of the standard. So this is now maintenance, which I know that Rexel don't necessarily do, but you guys have to be aware as part of the journey for your clients. There is a maintenance section, and there are standards under that. So they should be doing their weekly testing, and that's usually by the end user, and that's different call points each week. Confirm alarms operate. the voice alarm, if there is one, that needs to be tested, and any records should be in the logbook. So again, making records of making the tests and making sure they happen. Monthly, they should be checking any standby generators, and they should be run up for an hour, and then visual inspection of any of the batteries that they're using, if they've got central batteries and stuff like that. So again, you should have inspections and servicing, 2 visits per year carried out by a competent person, and that should be periodic tests and over the 12-month period. So pretty much everything should be tested. So that is a bit of an inspection and test logbook. Not exhaustive, but needs to be checked. And again, documentation should be in part of the fire log as the end user, as his responsibility. So again, testing over a 12-month period, 2 visits a year, visual inspection. You must test every device. If it's an analog system, you need to check the analog levels to make sure that the system, the detectors aren't too dirty and the analog levels are high, so you're going to be problems then with false alarm issues. Radio systems, any strength of the radio systems, cause and effect programming, everything works basically, and the standby calculation to make sure the batteries are in good shape too. Some of the non-routine inspections, that's a special inspection if you take over a system, repairs or any faults or any damages, any mods that you make, and again that can be put through the verification certificate, and actions to address any issues with false alarms, and inspection or test following a fire. So within the premises, there should be a single person responsible for all things fire, and they check the indication equipment daily. They ensure the maintenance arrangements are in place. They ensure that any changes are compliant, logbooks up to date, spare parts, keys are all available, and a plan of action for any pre-alarms. And that should all be within the logbook. And again, a good place to keep that logbook as well is your certification, and make sure everything's intact in that. So if there was for any reason an issue, it can all be documented. So these are just some of the annexes, A to G, which give you some guidance. If you do pick up the standard, you can look at choice of appropriate categories, typical noise levels, as I touched on earlier, in buildings, that's background noise levels, any issues with equipment for people with deaf or hard of hearing, method for calculating standby capacities, selection and application of detectors, and the model form of a logbook. And then obviously the Appendix G is all the model certificates that form part of the standards. And I think with 1 minute spare and 92 slides later, I think we're pretty much there. So I don't know whether there's been any questions, because I haven't been able to look, but if there are any, I'm sure Jamela will share my information. My colleague Colin Smith is on the call as well. And again, we've got a number of people within the business that can help you. So please just reach out if there's any questions further down the line. Read our document with the design guide. That's really helpful to recap on some of the things. So thanks again for all your time today. Appreciate it. Enjoy your weekend. We've got no time for questions now, but I'm sure Jamela will pick up that.
Yes, thank you, Paul, for such a lovely presentation. For anyone that was unable to download the handout, please just email us at marketing@rexel.co.uk and I will send you a copy. I will forward the few questions we have over to Paul, and I myself or Paul will respond to you individually. If there are any other questions, please just let us know. You will receive the CPD certificates directly from CPD, and it can take up to 4 to 5 weeks. So please let us know if you don't want to receive a certificate, but all attendees will receive one. Thank you so much for joining. There's a few questions at the end just to leave a review. That will be greatly appreciated. Thank you.